everybody, I'm Sankita from SMK Raja Ali. In today's lesson, we are going to learn Chapter 8, which is about lines and angles. By the end of today's lesson, you should be able to state vertically opposite angles and adjacent angles at two or more intersecting lines, and find the value of opposite angles and adjacent angles at two or more intersecting lines.
Who discovered angles first? The first person to discover angles is Eudemus, who regarded an angle as a deviation from a straight line. The second person is Carpus of Antioch, who regarded it as the interval or space between the intersecting lines. And the next person is Euclid, who adopted the third concept. Angles are used in daily life. Civil engineers and architects use angles for building infrastructures such as roads, construction work, animations, bearing tools, and crossroads. Angles are also used by carpenters to make chairs, tables, cots, and sofas. Where else can we find angles? Cloth hangers, scissors, arrowhead, partly open doors, pyramids, set squares, an edge of a ruler, an edge of tables, bicycle spokes, and wheels are examples of angles in real life. The form of different letters of the alphabet are also examples of angles.
Boys and girls, we can see a lot of intersecting lines around us. In these pictures, you can see lines intersecting and forming many different angles. There are lines intersecting at right angles. There are also parallel lines which would never intersect. Can you identify them? Have you ever been to Kuala Kangsar, Perak? One of the historical attractions in Kuala Kangsar is the Victoria Bridge. Let's take a look at this picture. Can you relate our topic for today to the architectural design of the bridge? Yes, the intersecting lines. Can you point to the intersecting lines? Good! The iron lattice girders form crossing lines. The crossing lines are called intersecting lines. Now, we are going to learn more about the properties of angles formed at two intersecting lines by doing a simple activity. Why don't you join me in doing this activity at home? We need a pencil, a ruler, 3 sheets of paper, and a pair of scissors or a paper cutter. I'm going to use a protector as well, but it is optional for you, okay?
The first folding ruler was created in 1851 by Anton Ulrich. The first flexible ruler, however, was invented in 1902 by Frank Hunt. Other forms of rulers include a desk ruler, a steel ruler, a carpenter's ruler, a seamstress tape, and even a tape measure. In the past, humans have used body parts as ways to measure distances or objects. For example, a hand or foot. The first noted ruler in history, however, dates back to 2650 BC. The first ruler did not look like the ones we have in our classroom. The first ruler was actually a copper alloy rod. However, there were rulers made of ivory in 1500 BC. A ruler has had many uses throughout history, but has always been a prominent tool in geometry. Different types of rulers can be used in different industries. For example, in tailoring, software, architecture, and design. The printing industry and other industries use different types of rulers as well. The most notable use of a ruler, however, is in office spaces and schools. A pencil case of a school pupil or a college or university student is not complete without a durable and reliable ruler. The first jigsaw puzzle was created by a map engraver called John Spilsbury in 1762.
Let's begin, shall we? First, draw two intersecting lines using a ruler and a pencil. I'm going to draw two diagonal lines on this A4 paper to produce the intersecting lines. These intersecting lines look like the letter X. Now, label the angles at the intersecting lines as A, B, C and D like this. Some angles are adjacent to each other. Some are vertically opposite to each other. For example, angle B and angle D are adjacent to angle A and angle C. But angle B and angle D are vertically opposite to each other. Can you identify which angles are adjacent to angle B? Good! Angle A and angle C are adjacent to angle B. Can you identify which angles are vertically opposite to angle B? Yes, angle D is vertically opposite to angle B. Next, cut along the intersecting lines. Be careful when you use the scissors. These looks like pieces of a jigsaw puzzle, don't they? Are you excited to know what we are going to do with these pieces of puzzles? I'm excited too! Alright, can you see that we have different sizes of angles here? Let's cut the angles and compare the sizes of the angles. Now put any two adjacent angles together. Oh look, boys and girls, they form a straight line. Two adjacent angles form a straight line. Can you recall what the value of the angle in a straight line is? Correct! The value of an angle in a straight line is 180 degrees. If you have a protractor, you can confirm the value. Place the midpoint of the protractor on the center point and line up one side of the angle with the zero mark. The other side matches with the 180 degrees mark. Now, reassemble the cuttings and try to put another pair of adjacent angles. These two angles form a straight line as well, right? So, the sum of two adjacent angles is 180 degrees. Okay, boys and girls, let's focus on the vertically opposite angles. One pair of opposite angles look bigger than the other pair of opposite angles. Don't you think that the size of these opposite angles look the same? Why don't we flip the cutout of the angle A onto the cutout of angle C and see what happens? Wow! These vertically opposite angles have the same size. Let's see if this is true for another pair of vertically opposite angles. Oh yes, it is true for this pair of vertically opposite angles as well. Do these properties apply only to one set of intersecting angles? Can it be the same for other shapes of intersecting lines? Let's draw again to check. This time, draw a different shape of two intersecting lines. Make sure the shape of the new intersecting line is different from the previous one. This is my new set of intersecting lines. This X looks thinner than the previous one. How about your new drawing? Can you show it to me? That's awesome! Now, label the 4 angles at the intersecting lines as E, F, G and H. As we can see here, the 2 adjacent angles, for example, angle E and angle F, still form a straight line. So, the sum of adjacent angles is still 180 degrees. Let's measure the size of vertically opposite angles. I'm using a protractor to measure the angles. Again, if you don't have a protractor at home, you can just cut out along the lines and stack the cutouts to compare the sizes. Just make sure to be careful when using the scissors, okay? The value of angle E is 156 degrees. Angle G, which is vertically opposite to angle E, also has the same value of 156 degrees. They have the same size. Now, let's check the value of angle F and angle H. The value of angle F is 24 degrees. Angle H, which is vertically opposite to angle F, also has the same value of 24 degrees. They have the same size too. You might get a different value depending on your drawing. That's totally fine. We just want to confirm the values of the vertically opposite angles. Your vertically opposite angles have the same size too, right? Boys and girls, based on this activity, we can conclude that the sum of adjacent angles at intersecting lines is 180 degrees, and the vertically opposite angles at intersecting lines have the same angle. Well, so far, we have drawn 2 sets of intersecting lines, which look like the letter X. There is another shape of crossing that we can draw, the cross which looks like the addition symbol, where the 2 straight lines intersect at a right angle. Do you know what is the value of a right angle? Good! The value of a right angle is 90 degrees. Now, draw 2 perpendicular intersecting lines. You can use the L-shaped corner of your ruler as a guide to get the right angle. Next, label the angles as I, J, K, and L. Can you see that we have the same size of angles here? Let's cut the angles and compare angles I, J, K, and L. All 4 angles seem to have the same size. Let's stack all the cutouts together. Yes, all 4 angles do have the same size. If 2 lines are perpendicular to each other, then all angles at the intersecting lines have the same size. All these angles are right angles.
The popularity of jigsaw puzzles went through rapid growth at the end of the 1800s. This was mainly due to 3 reasons. 1. Lithographic printing techniques were more sophisticated and wood could have a high quality print on its surface. These advanced printing techniques were perfect for jigsaws because this enabled much of the details of the images to be seen. Colors were also much brighter and more attractive as well. 2. Plywood. Plywood has layers of wood that are stuck together. This type of wood was easier to cut into intricate shapes, as well as being cheaper than other types of wood at the time. 3. The treadle jigsaw was invented, enabling jigsaw makers to create even more intricate shapes, with the added bonus of it being quicker to use at the same time. The invention of the treadle jigsaw made the puzzle makers more skilled at creating puzzles, which really tested the puzzler. Due to these 3 reasons, puzzle makers were able to cut puzzle patterns that would continue to challenge puzzlers. These included adding straight edges into the middle of a puzzle, dissected corners, and introducing theme whimsy shapes.
Now, let's consider this example. In the diagram, AB, CD, EF are straight lines. Line AB intersects with line CD and line EF. Can you identify the vertically opposite angles at the intersecting lines of AB and CD? Yes, correct! The 120-degree angle and angle V make the vertically opposite angles. Since the 120-degree angle and angle V make the vertically opposite angles, the value of V is also 120 degrees. How about angles V and W? Yes, they are adjacent angles. Can you state another pair of adjacent angles? Yes, the 120-degree angle and angle W also make another adjacent angle. Now that you have successfully identified the adjacent angles, let's find the value of W. The 120-degree angle and angle W make the adjacent angles. So, what is the sum of these two angles? Yes, that's right, 180 degrees. You're getting very good now. So, how do we find the value of angle W? We have to subtract 120 degrees from 180 degrees. 180 degrees minus 120 degrees equals 60 degrees. The value of angle W is 60 degrees. Let's move on to the right side intersection. Two lines, line AB and line EF, intersect at a right angle. Do you recall what the value of a right angle is? Good! A right angle has a value of 90 degrees. Can you identify the vertically opposite angles at the intersecting lines of AB and EF? Yes, the right angle and angle X are vertically opposite angles. You now know that opposite angles have the same value. So what is the value of angle X? Yes, that's correct. The value is 90 degrees. How about angles X and Y? Yes, they are adjacent angles. Can you state another pair of adjacent angles? Good. The right angle and angle X are adjacent angles too. Now, let's find the value of Y. The sum of adjacent angles is 180 degrees. Again, what do we need to do in order to find the value of Y? Yes, to find the value of Y, we must subtract 90 degrees from 180 degrees. 180 degrees minus 90 degrees equals 90 degrees. The value of Y is 90 degrees. Good job, boys and girls! Now let's try a more challenging question. In the diagram, POQ, ROS and TOU are straight lines. You are asked to find the values of X and Y. Let's find the value of X first. Since the angle ROU and angle TOS are vertically opposite, they have the same value. Now that we know the sum of angle TOV and angle VOS equals to 55 degrees, Can you suggest one equation to represent the relationship? Excellent! X plus 55 degrees equals 85 degrees. We need to solve the equation to get the value of x. X equals to 85 degrees minus 55 degrees. So the value of x is 30 degrees. Next, we need to find the value of y. Can you see that y and angle POR are vertically opposite angles at the intersecting lines of AB and EF? Angle POR has the same value as y as well, right? I will label the angle POR as y. Together, the angles TOP, y, and ROU form a straight line. What is the sum of angles on a straight line? Correct! Angles on a straight line add up to 180 degrees. We can write the equation as 60 degrees plus y plus 85 degrees equals 180 degrees. Next, we need to solve the equation to get the value of y. Y equals to 180 degrees minus 85 minus 60. So the value of y is 35 degrees. Awesome! You are now able to state and find the value of vertically opposite angles and adjacent angles at two or more intersecting lines.
Who determined that a circle should be divided into 360 degrees? The same people who invented the wheel about 6,000 years ago, the Mesopotamians, who loved the number 60. It is a useful and easily divisible number, which made it ideal for both early mathematics and commercial trade. The Mesopotamians passed the base 60 numerical system to the ancient Egyptians, who used it to divide a circle into 360 degrees. The 360-degree circle worked out great. The Egyptians loved perfect triangles, and they discovered that exactly 6 of them fitted into a circle. Therefore, 6 triangular slices of 60 degrees each made for a sensible 360-degree dissection of a circle. The Egyptians, who invented the degree symbol, also came up with the first calendar based on a 360-day year, which is only off by 5.25 days. Since then, the 360-degree circle has made its mark on time itself. When time was first recorded on the face of a circle, it was an easy leap to divide hours into 60 minutes and minutes into 60 seconds.
Do practice to answer other questions in the textbook for enrichment. Thank you for watching. I hope you find this lesson helpful. Have a great day. Goodbye, everyone.